All right, here goes. Before we get started on these two topics today of simple and compound interest, we are going to do a little bit of a review. I know this is something that you're comfortable with already, but I think it can't hurt to talk about it. Just the idea of exponents. We used exponents in chapter 1, probably most notably with the Pythagorean theorem. But just as a reminder, if we have something like 4 raised to the third power, what that means is we're going to take this number called a base of 4 and multiply by itself 3 times. So this is 4 times 4 times 4. Be careful. It's really easy sort of have in your head, oh, 4, 4, and 4, that's 12. Make sure you're patient and careful as you do this, and you go 4 times 4, that's 16, times 4 again. Okay, so 4 raised to the third power is 64 because we've multiplied 4 by itself 3 times. And it's just a simple reminder of what exponents look like and how we use them. Exponents are going to be really important for us as we go through the compound interest formula later on today. So I just want to make sure we're all on the same page when we talk about exponents. We're also going to have some equations that we're going to solve in this section. And this is just a little reminder. Again, I know we've solved equations before, but just a reminder to refresh our memories a little bit. The main thing about an equation is anytime we're solving an equation, what we're looking for is what value of this variable here would make the equation true. That's what we're trying to do when we solve an equation. What value or values of x would make this a true statement? That's what we're after. And so with that in mind, we attack this algebraically. We're not going to guess by throwing things in there and hoping they work. Instead, we're trying to get this x by itself. So we're trying to get the term with x by itself. And so we look at that side of the equation as a whole that we're going to peel from the outside in. And so the first thing we're going to get rid of in this equation, if we want to solve this, we have the left side of the equation over here. What do we want to do first? What do we want to do first to try to get this term by itself? And I'll give you a little push. We're trying to get rid of that negative 11, that minus 11. We're trying to get rid of it. What do we do to get rid of subtract 11? Add 11 to both sides. Perfect. Thank you, Ashley. We're going to add 11. And we do that because we want this negative 11 to cancel, so we add 11 on the left-hand side. But if we add 11 on the left, we also have to add 11 on the right. And then once we've done that, now the only thing remaining on the left is 3x. 19 plus 11 will be 30 on the right. Since I asked about the last one, I'll ask about this one too. Now we're down to just that term 3x. But keep in mind, we are trying to get x by itself. What do we need to do to make 3 times x? How are we going to get that multiplying by 3 to go away? And very good, Nicole. We're going to divide by 3 on the left. That makes these cancel. That was our whole goal, was to get rid of that 3 so we'd have x by itself. If we divide by 3 on the left, we'll also divide by 3 on the right. And that leaves us x over here and 10 over here. And we have now solved this equation. We know that this would be a true statement if x is 10. I know some of you are very comfortable with algebra. And so to you, I apologize for being so drawn out with those explanations. But I also know that there are students in the class who aren't that comfortable with algebra. And I want to make sure that every one of these steps that we do makes sense to you, rather than us just ripping through them. Okay, now let's talk simple interest. Simple interest can apply to money that's invested, meaning you earn interest, or borrowed, meaning you have to pay interest. So, and we're going to see situations of both where you earn interest and where you have to pay interest. But the formula that drives simple interest looks like this. I equals P times R times T. Let's talk about what those components are. The I is the amount of interest. The P is the amount of principal. And it's important for us to make a note that principal, well, interest, I get it. That's what I earn when I put my money in the bank. But principal, what is that? Principal, that's the money that you start with. And so if you're investing money, it's how much you put in. And if you're borrowing money, it's how much you borrowed. So either way, that P for principal represents the starting amount. R is going to be our interest rate. And then finally, the T here is for time. How long was the money invested or borrowed? One key thing about time is that in this formula, it is always in terms of years. So what we're going to plug into this formula for time is going to be time measured in years. How that comes into play for you, it's very simple. If we're told that money was invested for 4 years, we're just going to put a 4 where the T is. But what if the money was invested for 6 months? If money was invested for 6 months, what am I going to use T for T? How much of a year is that? What would I use for T if it's invested for 6 months? Excellent, Kevin. 0.5. That's perfect. We could use 0.5. And if you were thinking, well, it's half of a year, so we would use 1/2. That would be correct also. The first thing that we would do when we go to plug this into the formula would be to convert that to a decimal. So Kevin's 0.5 is exactly the right thing there. One little note I want to make, and I'm pretty sure I mentioned this on Tuesday, but as we go through chapter 2, when we're working on problems that involve money, we are going to round to the nearest cent, which means we're going to round to the nearest hundredth. It's just sort of a reminder to keep back in the back of your mind. In our online homeworks and our quizzes and our exams, I'm pretty sure every question will say round to the nearest cent. But in case there's one in there that doesn't have that instruction, if the problem involves money, your default is to round to the nearest cent. And then it's important for you to know when you see round to the nearest cent that you know that means round to the nearest hundredth. 2 places past the decimal, just like you'd see on a price sticker. You know, $2.79. We're going to round 2 places past the decimal. All right, let's look at how this simple interest formula works. How much interest would be earned if $500 is invested at 3% simple interest for 10 years? Later on today, we're going to talk about compound interest. And you may be thinking, how am I supposed to know whether I use compound interest or simple interest? And the great thing is the problem will tell you. If you read this, how much interest would be earned if $500 is invested at 3% simple interest for 10 years? So right away, we know because this problem involves simple interest, we're going to use the formula I equals PRT. We'll read that question again. How much interest would be earned? So I, that's the thing we're looking for. We're trying to figure out what I is. $500 is invested, so that's going to be our principal. 3%, that's going to be our rate. And 10 years, so that's going to be our time. So very straightforward here. The problem tells us you're looking for interest, you know the principal, you know the rate, you know the time. We're just going to plug them in. And when we do that, we're looking for interest, and that's principal, which is $500, times the rate, which is 3%. It's a key point here that we are going to convert that to a decimal when we plug it in. Be careful. 3% is going to be 0.03. not just 0.3. 0.3 would be 30%, and we don't want that. 0.03 would be 3%. And then time is 10 years. And now to finish this up, all we need to do is multiply those three numbers over there. And we'll have 500 times 0.03 times 10. And the amount of simple interest that will be earned is $150. Pretty straightforward, but if you have any questions on how any of those numbers got plugged into those spots, or any questions about what we did to find the amount of interest, let me know. All right, let's look at another one. Find the future amount A if $400 is invested at 5% simple interest for 4 years. So I read through the question. Find the future amount. We'll come back to that. If $400 is invested at 5% simple interest, right there it is in the question, simple interest. I know I'm using I equals PRT. And then, okay, well, $400 was invested, so that's my principal. The rate was 5%, and the time was 4 years. So I have PRT. The thing is, this formula that I have over here that I'm pretty comfortable with already, I equals P times R times T, that gives me I, the amount of interest. But this question doesn't ask for the amount of interest. Instead, this question says, find the future amount A. So that's a new component to our whole study here that we haven't seen yet. And what that refers to is A, which is the future amount. This can also be called future value. So the future amount or future value of this investment, what that is what is it going to be worth at the end? So it's not how much interest did you earn, it's how much is this investment worth when all is said and done. And we have a second formula we're going to use for that. And that formula is that A equals P plus I. Just to make sense of this formula, what it's saying is this. The future value, the future amount of this investment is the principal, the money you put in to start with, added to the interest that you earn. So if you take how much you put in and you add the interest on top of that, that's how much you have at the end. And that's what we call the future amount or future value. Those are synonyms. They mean the exact same thing as each other. What's going to happen here then is we are going to use the formula for simple interest to find out how much interest is earned. But after we do that, then we're going to have one more step to do. So here goes. First, we find the amount of interest, and that's going to be the principal multiplied by the rate of 5%. Be careful when you convert that to a decimal. Multiplied by the time, which is 4 years. And so the amount of interest earned here would be 400 times 0.05 times 4, or $80. If the question had said, find the amount of interest earned, like the last one did, this one, how much interest would be earned? If it said that, we'd be done, and our answer would be $80, and we're moving on to the next one. This is one of those cases where you'll hear me say it over and over again, especially in this chapter. Make sure you answer the question that's being asked. If it says how much interest is earned, then we're done. But it didn't say that. Instead, it said, find the future amount. So we don't have that yet. We do know what the principal was, and now we know how much interest was earned, so we can use this formula to find out the future value. The future value is going to be the 400 that we started with, plus the 80 that we earned in interest, so the future value of this investment is $480, and that's the answer to our question here. The future value of this investment is $480. Let me know if you have questions on that before I give you a chance to try one. All right, terrific. Here goes. Find the future amount if $750 is invested at 4% simple interest for 6 years. I'll set up a poll for you on this and give you a chance to try it. So the two keys here are recognizing that it's a simple interest problem, so we know which formula to use to start, and then recognizing that we're not being asked for the amount of interest that was earned. Instead, we're being asked for the future amount. Those are the two keys to this one. Just as a reminder, if you come up with an answer that's none of the choices, pick the one that's closest to yours. That way I'll know you've had enough time to solve it. I think we'll go another 30 seconds and then talk through it. Practice these. I encourage you to practice them because these are the types of questions you can expect to see on the homework and on the quiz and eventually on an exam. If you can solve them now, that's a great indicator that you're setting yourself up to be successful down the road. And more importantly than that, probably, is if you're having trouble with them now, we want to identify where those difficulties are and try to fix them right now, while it's on the stove, so to speak. All right, let's take a look at where we're at. All right, unanimous. Very good. That's great news. Okay, so let's take a look at this one anyway, just to finish it up with clarity. We've got find the future amount A. So I know I'm going to use this at some point because I've been asked for the future amount. If 750 is invested at 4%, simple interest, I equals PRT. I can plug in to find my amount of interest that was earned, which will be the principal multiplied by the rate multiplied by the time. We'll multiply those together. 750 times 0.04 times 6. And we can see that $180 of interest has been earned. There's a little bit of a pull to want to answer 180. I'm proud of y'all for not doing that. 180 is the amount of interest, but we weren't asked for the amount of interest. We were asked for the future amount. So we're going to need to use this formula to find the future amount, which is the principal plus the interest that was earned. And that's how we arrive at a future value of this investment of $930. That went great. So I feel pretty good about where you are, but let me know if you have any questions at all. All right. One of the things that's true about the formula for simple interest is it has 4 components: I, P, R, and T. So far, we've just looked at finding the interest. But the truth is, if we know any of the 3 pieces, we can find the 4th one. And this problem gives us an example of that. A $3,000 investment earned $400 in simple interest over a 3-year period. What was the interest rate? So what's different about this one is now we're being asked for the interest rate. We read the problem. It says a $3,000 investment earned $400 in simple interest. That points me right here right away. Over a 3-year period, what was the interest rate? And so this time, what I'm being asked for is R. I'm going to know the other 3 pieces, and I'm going to have to find R. Okay, well, let's see how that plays out. A $3,000 investment, so that's my principal, earned $400 in interest, so that's I, over a 3-year period, that's T. So in this problem, I know P, I know T, and I'm looking for R. Okay, well, we can do that. Let's plug these in and see how it goes. The amount of interest was $400. The principal was $3,000. R is the thing I'm looking for. I don't know what that is. And then T is 3 years. So now what we've got in this equation that we want to solve for R. There are a couple different ways you can go here, but my advice is let's go ahead and clean up whatever we can over here on the right-hand side first. These are all just multiplied together, so we can multiply them in any order we want. We'll go ahead and multiply that 3,000 times 3 so that we have 400 equals 9,000 times R. I have 9,000 times R. I want to get rid of that 9,000. How do I get rid of that 9,000 again? What do I have to do to get rid of 9,000? so that I get the R by itself. And I know half of you probably know what to do. You can type it in there for me, and you can all type it in there for me, and that'll be just fine. Because the more people that say they know what to do, that convinces me that everybody knows what to do. We're going to divide, and that's true. We're going to divide by 9,000 on the right, because those will cancel, leaving just the R. If we divide by 9,000 on the right, we also have to divide by 9,000 on the left. And all that's left on the right-hand side is the R. That was the whole point of that step. And now on the left, we have 400 divided by 9,000. And let's see, I get this decimal, 0.044444, and that keeps repeating. At this point, we have to think about what we want our answer to look like. If you think about the problems we've done up to now, the interest rate has always been given to us as a percent. Right now, what we have is a decimal. So we need to convert that decimal to a percent. You can do this a couple ways. You can multiply by 100, or if you're comfortable with it, just move the decimal 2 places to the right. And so now we have 4.44444%. And the only thing left to do is go back and say, did this question tell me how to round? Sure enough, it said round to the nearest hundredth. So we'll do that. So we'll find the hundreds place. We'll look 1 space to the right. The number there is 4 or lower, so we're going to round this down to 4.44%. So if a $3,000 investment earned $400 in simple interest over a 3-year period, then we know the interest rate must have been 4.44%. Are there any questions on what we did there before I have you try one? It's a little more involved than what we've done up to this point. So if you do have questions, don't be shy about asking them. Okay, let's try one. Here goes. A $2,500 investment earned $900 in simple interest over a 5-year period. What was the interest rate? And round this one to the nearest tenth. I'll make a poll for this and give you a chance to try it. A little more involved in what we've done up to now. In some ways, this is about as challenging as simple interest problems get, really. And that could be a very good thing for some of you to hear, that if you're comfortable with this, then you're in a really good place with simple interest. We do have one more problem I want to look at with simple interest, but trying to determine the interest rate is usually the most challenging type of simple interest problem we work on. We'll go another 30 seconds and then talk about this one. If you need more time, let me know. If you see an answer, if you come up with an answer that's none of the above, then go ahead and pick the one closest and make sure you ask questions when we talk it over. Well, not unanimous, but strong agreement. That's really good. Okay, let's go back and take a look at this. We'll talk through it. If you see something that you're not sure of, make sure you ask about it. So we walk up and this is the first thing we see. A $2,500 investment earned $900 in simple interest. As soon as I see that, I'm thinking this formula. Over a 5-year period, what was the interest rate? So in this one, I'm being asked for the interest rate, so that's the thing I'm trying to find. Let's see what they've given me. $2,500 investment, so that's the principal. That's how much we started with. It earned $900 in simple interest, so that's how much interest we earned over a 5-year period, so that's our time. And we're looking for the rate. So we know 3 of the 4 pieces, and anytime we know 3 of the 4, we can find the 4th one. So here the interest was $900. The principal was $2,500. The rate we don't know, and the time was 5 years. If any of those numbers don't make sense, make sure you ask. To clean this up and solve for R, we're going to go ahead and multiply 2,500 times 5 on the right-hand side there, just to simplify that side of the equation as much as possible. We'll still have 900 over here. We'll have 2,500 times 5, just 12,500. We're trying to get R by itself, so we need to get rid of 12,500. So we're going to divide by 12,500 on the right. Those cancel. And we're going to divide by 12,500 on the left. Nothing left but R on the right-hand side. And so all we need to do is divide on the left. One thing important to note is what we have over here is 900 divided by 12,500. It's not always big number divided by little number. This time it just happens to be 900 on top, and it's always top divided by bottom. So 900 divided by 12,500. And let's see, for that one, we end up with 0.072. That answer is in the form of a decimal, but if I'm asked for an interest rate, I need to give the answer in terms of percent. So I need to move that decimal 2 places, and we end up with our 7.2% as our interest rate. The poll went well, but let me know if you have any questions about anything that happened in there. There's no, if we all already knew everything, we wouldn't have to practice at all. So make sure you ask questions if you have any. Okay, we'll keep going. This simple interest question has one little twist in it I just want to make sure that you're aware of. Alex invested $5,000 at 8% simple interest, and the total amount returned to him was $7,400. For how long was the money invested? There's a couple of things I want you to recognize right away here. First, and probably most importantly, is Alex invested $5,000 at 8% simple interest. So right away, I equals PRT. Okay. The total amount returned to him, well, that's new. We haven't seen that before. The total amount returned to him. That represents our future amount or future value. Either of those, they mean the same thing. Those are interchangeable words. Future amount, future value. The total amount returned to him, this is how much they gave him at the end. He gave him 5,000, and when the time was up, they gave him back 7,400. This is not the amount of interest that was earned. Instead, this 7,400 is the future amount, the future value. That 7,400 here, this is our A. And what that tells us is here, we're going to need to use A equals P plus I as part of the process here. So it's very important to note, the interest wasn't 7,400, it's the future value that's 7,400, and that lets us know we need to use this formula also in this question. We can sort of make a note here that he invested 5,000, so that's the principal. We can see that 8% is the rate, and we're being asked for how long, so we're looking for the time. So the thing that we're looking for here is the time. if I'm going to find the time, I'm going to need to know the principal. Okay, got it. I'm going to need to know the rate. Okay, got it. I'm going to need to know the amount of interest. I don't have that yet, but I can find it. So here, the first thing we're going to do is we're going to use A equals P plus I to figure out how much interest Alex earned. And so A, the future value is 7,400, and that's going to equal the principal plus the interest. I don't know how much interest there is yet, but I can find it pretty easily. What do I need to do to get this I by itself? If I want to solve for that I, what's the operation I need to do to get I by itself there? And some of you probably have done this in your head and said, well, I can see how much interest he earned because I can see the difference between those two numbers. Difference being a very important word. How are we going to get rid of that 5,000 so that we have I by itself? Excellent, Jessica. We're going to subtract 5,000 on both sides. That's exactly right. On the right-hand side, I'm going to subtract 5,000 so that those cancel, and all I have left is the I. If I subtract 5,000 on the right, I also have to subtract 5,000 on the left, and that leaves me with 2,400. So the amount of interest earned is 2,400. Some of you may have said, well, no kidding. I mean, he started with 5,000, he ended with 7,400. So obviously the amount of interest that took him from there to there was 2,400. If you see that and it makes perfect sense to you and you're comfortable with it, it's totally fine. If you would rather, you know what? I know A and I'm looking for I, I'm going to use this formula, and you use the formula to get 2,400, that's great too. It's totally fine. Whatever you're comfortable with and you're getting the problems right. You know, you don't want to avoid using a formula and then get it wrong. It's fine if you recognize, well, the interest was 2,400. Excellent, great, go with that. If you'd rather use the formula, or you're more apt to be correct if you use the formula, then use the formula. Now, we're not done yet. Remember, always go back and say, did I answer the question that was being asked? And the question that was being asked here was, for how long was the money invested? I'm looking for T. I still need to find this T right here. So now I need to use the other formula, except this time I know what I is. The interest was 2,400, and that's equal to the principal times the rate, which was 8%, times the time. Just like we did before, we're going to go ahead and clean this up a little bit by multiplying those together. So 5,000 times 0.08 is 400. The number doesn't really mean anything by itself. It's just a piece of the puzzle that gets us on the road to figuring out how long it was invested. So that's 400 times T. And now to get that T by itself, we'll divide by 400 on the right, divide by 400 on the left, and then we can see that T is equal to 2,400 divided by 400, 6. So for how long was this money invested? It was invested for 6 years. The key here is we had to do two things, not just one. The first thing we had to do was avoid reading this question and just sort of making the assumption that this is the amount of interest that was earned, because it's not. This was the amount of money they gave back to Alex at the end. So it was the future value. So, okay, you gave me future value. If I know the future value and I know the principal, I can find the interest. And then once I found the interest, now I can use my simple interest formula to figure out how long the money was invested for. Are there any questions on that before we put simple interest to bed? All right, fantastic. Before we dive into our other formula today, I want to do a little more review. This time it's about order of operations. We talked about order of operations back in chapter 1, and we talked about them in this structure here. Please excuse my dear Aunt Sally. And what that means for us is if you have any work to do inside parentheses, that goes first. After that's all done, look and see if you have any exponents. Then look if you see if you have any multiplying and dividing to do. We're going to do that left to right. And then finally, if you have any adding and subtracting left to do, we'll do that left to right. We want to keep that in mind as we simplify an expression that looks like this one over here. 150 times, parentheses, 1 plus 0.12, parentheses, raised to the 8th. So if we want to simplify this, keeping order of operations in mind, the first thing we need to do, well, I've got parentheses. I do have work to do here inside parentheses. Sometimes parentheses just help keep things organized. Like when we do principal times rate times time. Those parentheses they're just keeping the numbers organized for us. Instead of using just a dot in between them, we can use parentheses. It shows that the numbers are going to be multiplied. But if you look inside these parentheses, there's no work to do inside them. They're just keeping the numbers organized. That's not the case we have in the one we've been given here. In this one, we've been given something to do inside those parentheses. We need to add 1 plus 0.12. So we'll do that. And we'll get 150 times, let's see on my calculator over here, I'll have 1 plus 0.12, 1.12. And that needs to be raised to the 8th power. All right. I don't have any more work to do inside parentheses. That's all done. Now I look for exponents, and sure enough, I have one. I have this 8 up here that's an exponent. So now what I need to do is I need to raise 1.12 to the 8th power. And I'm looking at my calculator, and I'm seeing a button on there that's x squared, and I'm seeing another button on there that's x to the 3rd, but I don't have a button that's x to the 8th. I don't have that. How am I going to raise a number to the 8th power? What you should see on your calculator is a button that is either x to the y to the x, or a caret symbol like that. So you should have one of these 3 buttons, x to the y to the x, or a caret. What that button does is it allows us to take any number we want and raise it to any power we want. Kind of depends on the calculator you've got, but for the most part, they work the same on this one. We'll have the 1.12 on our calculator. We'll hit the x to the y to the x, or caret button, then enter the 8, and then either equals or enter, depending on what your calculator is. And when you do that, when you raise 1.12 raised to the 8th power, you should get 2.47596, and that keeps going. And so we have 150 times 2.45796, and that keeps going. I'm just going to leave that number sitting there on my calculator. My calculator is going to be my friend here because I'm going to leave that number sitting on it. I only have one more step to do, and that's just to multiply by 150. So we'll go ahead and leave that sit there, multiply by 150, and get 371.3944, and that keeps going. Since I'm at the end, now I'll follow these instructions over here that tell me to round to the nearest hundredth. We'll find the hundredths place. We'll look one space to the right. That's 4 or lower. So we'll round this down to 371.39. A couple of things I want to ask before we go forward. Let me see here. Let me make sure I put that in correctly. 1.12 raised to the 8th. 2.47596. Oh, did I? 2.475. Oh, okay. I switched these two up when I wrote it. Yours is correct, Ron. That's correct. So that number, 2.47596. Very good. Thanks. Y'all keep me in check. So I just switched that 7 and 5 around when I wrote it down, but raising 1.12 to the 8th, you should get 2.47596. If anybody has questions about what we did there or how to use this button, let me know before we go forward. I want to make sure you're comfortable with that, because otherwise you won't be able to do our compound interest problems. So this x to the y to the x caret button is a really important one for us. As we go forward, I want to make sure you're comfortable with it. Okay. Compound interest. The formula for compound interest is more complicated than the one for simple interest, but if history is any indicator, I don't think you're going to have a whole lot of trouble with it. Let's take a look at what the formula looks like first, and then we'll talk about all the pieces that are involved. Okay, so there's our formula for compound interest. A equals P times 1 plus R over N raised to the N times T power. Okay, there's a lot going on here. Let's talk about all the bits and pieces. First, we'll talk about what you already know. A over here, we've seen that before. That's our future amount, which is also called the future value. P, that's still principal. R, that's our interest rate. And T, that's time. And just like before, that's in terms of years. So at quick glance, you already know what almost all of this is. We know what A is, the future value. We know what P is, the principal. That's just the number 1. We know R is the interest rate, and we know T is the time. So the only thing that's new in there at all is this N. We have not seen this N before. That's the thing that's new. The same number is going to go in both of those spots. So whatever N is goes in both of those places. And what N is it's the number of compounds per year. Essentially what it is how many times a year do they calculate the interest on your investment or your loan, depending on which it is? How many times a year do they do that? And there are 3 main ones that we're primarily concerned with. The first of those is if interest is compounded monthly. If that happens, they're going to compound interest 12 times per year. So the number of compounds per year is going to be 12. There's also quarterly, which if they're going to compound interest quarterly, that's every quarter of the year. So every 4th of the year. So they're going to compound your interest 4 times a year. And N will be 4. And then there's also annually, where it's just once a year. So the number of compounds per year is 1. Monthly, quarterly, and annually are the common ways to compound interest, and those are the ones that we're most interested in, is when N is 12, 4, and 1. There's one key point about this formula that I want to make sure to highlight, and the simple interest formula that we saw earlier was I equals PRT. If we just plugged in over here, what came out was interest. Compound interest formula is different from that. Now, if we plug in all this stuff over here, what comes out is the future value. So that's a little bit different than simple interest. Simple interest would spit out interest. Compound interest instead spits out future value. We'll keep that in mind as we go through working with the formula for compound interest. All right, let's see how this thing works. Find the future amount if $200 is invested at 6% compounded monthly for 5 years. Now, earlier I said, we're working on simple interest and compound interest. How am I going to know which formula to use? It's a perfectly reasonable question. Well, you'll remember all those simple interest formula questions said simple interest right in them. And this one, find the future amount if $200 is invested at 6% compounded monthly. Right there, it's telling me to use the formula for compound interest. So I know the formula I'm going to use here is this one. Okay, let's see what we have and see what we're looking for. Find the future amount. So it says find the future amount. So I'm looking for A. So it's going to have to give me all the stuff I need over here to plug in. Well, let's see what we have then. Let's see. If $200 is invested, so that's our principal, 6%, so that's our rate, compounded monthly, that means N is going to equal 12, and 5 years, so that's our time. So we know P, R, N, and T. We know P, R, N, and T. We have everything we need to plug into this formula, and then we'll simplify it to figure out the future amount. Here goes. You let me know if something goes in somewhere and you don't know why it went there. We're just going to plug in for now. So the future amount is going to be the principal, which was $200, times 1 plus R, which is my rate of 6%. Make sure you convert that to a decimal. Over N, which is 12 because it's compounded monthly. That's 12 times a year, so N is 12. The same number goes up here for N, and then T is 5 years. We've got everything plugged in. The only thing left for us to do is simplify this on the right-hand side using order of operations, which is exactly what we did when we did that review problem with order of operations. So let me know if there's anything that you're not sure where it came from at this point. Otherwise, I'm going to go ahead and start working through this. One thing I am going to do first that might feel a little bit out of line, but really I'm just cleaning this up, is we're going to go ahead and make that exponent be one number. We're going to do the 12 times 5 up there in the exponent. Essentially what the reality is here is order of operations applies to up there in that exponent also. And we're going to go ahead and do that first and make that a 60. And essentially what we're saying here is this. I've invested $200 at 6% compounded monthly. And over the life of this investment, that's going to be 12 times a year for 5 years. They're going to compound my interest 60 times. Now we've got this all cleaned up and we're ready to attack it. We're going to start inside the parentheses. And what I want you to keep an eye on here is how our calculator is a huge help to us. It's going to carry our number all the way from the beginning to the end. We have stuff inside parentheses, so we need to do that first. So we'll have 200 times 1 plus 0.06 divided by 12. Inside these parentheses, I have adding and I have dividing. Dividing goes first. So I'm going to do that 0.06 divided by 12. And I get 0.005. Be careful here. It's common to get really small numbers. Oops. I already did the division, didn't I? And that needs to be raised to the 60th power. We're not done inside our parentheses yet. We need to add those two numbers inside there. We still have work to do inside the parentheses, so we'll do that next. We're going to add those two numbers, and here's where the calculator part comes in. First thing I did was put 0.06 in my calculator. And I said, okay, well, that 0.06, it needs to get divided by 12. So let's do that. Don't hit clear. Just leave that 0.005 sitting on your calculator because we're going to need that again. And we need it right now. And what we're going to do is we're going to add 1 because that's the next thing to do. I've got 0.005. I need to add 1. So that's what we'll do. We'll add 1. And now I have 1.005 that needs to get raised to the 60th power. Okay, that's what I need to do next then. Up next, I need to raise this to the 60th power. I'm just leaving that 1.005 sitting there on my calculator. I'm going to raise it to the 60th power. And that's my x to the y to the x, or caret button, depending on which one you have. Because we want to raise any number to any power. And it's that 1.005 that we want to raise to the 60th power. And I get a really long decimal. That's okay. It's 1.3488, and that keeps going. I don't really need to write the whole thing down, though. I'm just going to let it sit there on my calculator. I'm going to let my calculator hold it. I only have one more step to go, and that's just multiplying by 200. So we'll go ahead and leave that number sit there, and we'll multiply by 200. And I get 269.7700, and that keeps going. And now I'm done. I'm at the very end. I don't have any more steps to take, but this question is about money. It said, find the future amount. This is a money question. So this answer here that I have, I want to make sure I round that to the nearest cent, which means I want to round it to the nearest hundredth. So what I'll need to do then is go find the hundredths place, which is here. Look, one space to the right. That's 4 or lower, so I'm going to round this down. $269.77. That is going to be the future amount, the future value of this investment at the end of the 5-year period. Started out with $200, ended up with $269.77. Are there any questions about what we did there to find that future value using the formula for compound interest? Outstanding. Let's do another one. Find the amount of interest earned if $750 is invested at 4% compounded monthly for 8 years. Okay, well, let's see what happens here as we read through this question. The first thing I notice is find the amount of interest earned if 750 is invested at 4% compounded monthly. Right there it is. Should I use simple interest here or compound interest? I'm going to use compound interest because it told me to. Okay, fantastic. If I want to find this out, let's see here. It says find the amount of interest earned. Well, interest earned is not in here anywhere at all. You may not know this, but I'm going to ask you and see if anybody comes up with it. This formula is going to give me future value, but what I've been asked for isn't future value. What I've been asked for is the amount of interest earned. How am I going to find the amount of interest earned? What am I going to use to figure out how much interest was earned? And if you don't know this one, that's okay. We're going to talk about it, I promise. I'm just curious if anybody's comfortable with, okay, this formula is not going to give me the amount of interest earned. How am I going to get it? And like I said, it's okay if you don't know. We'll go ahead and start working on this, and you'll see it when we get to the end. First thing I'm going to do then is say, all right, well, I'm going to go ahead and find the future value here, and then we'll figure it out from there. So let's see. In order to find the excellent, Hugh, that's excellent. Very good. So you got it exactly right. I need something that if I know the future value, I can find the interest, and there it is. If I know the future value, I've been given the principal, I'm going to be able to find the amount of interest. So what's going to happen here is this. The first thing I'm going to do, and we've seen this before, where we had to use two formulas in the same problem. First thing I'm going to do is I'm going to use this formula to find the future value. And once I know the future value, that's when I'll use this formula to answer the question of how much interest was earned. All right, so let's dive into finding that future value first. Future value is going to be principal, which was $750, times 1 plus the interest rate of 4% over n. Gosh, I'm going to go back and label stuff. I'm more comfortable when I label it. Find the amount of interest earned if 750, that's my principal, is invested at 4%, that's my rate, compounded monthly, so that means n is going to equal 12 for 8 years, so my time is 8. Okay, now I'm more comfortable plugging this stuff in. I'm going to go back and make sure I've done this correctly. P, that's principal. Okay, I got the 750 right. 1 plus R, which is my 4% interest rate over N. Okay, N is 12 because it's compounded monthly. 12 also goes here, and the number of years is 8. That's my time. First thing we'll do is clean up that exponent up there. We'll go ahead and multiply those, and I'll have 750 times 1 plus 0.04 over 12 raised to the 12 times 8, whatever that is, 96. What that is over the life of this investment, there's going to be 96 times that the interest gets compounded. 12 times a year for 8 years. Multiplying those gives us the total number of times the interest is going to be compounded. Now we're back to this sort of setup again where we want to follow order of operations. We're going to divide first. And when we do that, we'll have 750 times 1 plus 0.04 over 12. Whew. Okay, there's a decimal for you. 0.0333333. And that keeps going. The good news is, I just need to keep track of this. I don't need to write down a whole lot of it because I know that I'm going to let the calculator just sort of carry this number forward for me. Up next, I need to add these two together. I still have work to do in the parentheses. I'm going to add those together. And so when we do that, we'll have 750 times 1.0033, and that keeps going. That needs to get raised to the 96th power. On my calculator, what I've done so far was I put in 0.04 divided by 12, and I got that decimal. And then I'm like, hey, the next thing I need to do here is add 1. So I'll just do plus 1. Okay, now I've got this decimal on my calculator that needs raised to the 96th power. So we'll do that. And that's where I'm going to use my x to the y to the x, or caret button to help me raise that to the power. So we'll do that, and we'll have A is 750 times whatever we get when we raise that to the 96th power. Looks like 1.3763. And that number keeps going. But again, I'm just going to let the calculator hold on to it for me because one more step I have to do here to get the future value is just multiply by 750. So we'll go ahead and multiply by 750. And I get 1032 rounded to the nearest cent. 0.30. I'm going to go ahead and write that one down. 0.29633. And we want to round this to the nearest cent. I'm done with all my calculations as far as future value goes. Now I can round to the nearest cent, which is the nearest hundred. I look one space to the right. That's 5 or bigger, so I need to bump this up to a 0, which bumps this up to a 3. Essentially what I'm rounding there is from 29 cents up to 30 cents. And so what I end up with here for my future value is $1,032.30. Okay, if this question said, find the future value if 750 is invested at 4% compounded monthly for 8 years, I would be finished. What I have here is the future value. But this question didn't ask for future value. This question said, find the amount of interest earned. And so while this is an important part of the solving process, I'm not quite done yet. Now what I need to do is figure out how much interest was earned. I've got a formula over here that will help me. If I know the future value is 1032.30 and I know the principal was 750, then I just have one simple step to find out how much interest was earned. All we'll need to do here to figure out how much interest was earned is subtract 750 from the right, subtract 750 from the left. When we do that, we find out that the amount of interest that was earned here is $282.30. And because the question said find the amount of interest that was earned, that's the answer to our question. Some of you may be very comfortable with the idea of, well, when I see this and I get here and I say, well, that's how much he ended up with, and that's how much he started with, can I just subtract those to find the interest? Yes, absolutely. That's exactly what we did down here. We just subtracted to find out how much interest was earned. If you're more comfortable with the formula, don't hesitate to use the formula. If it's very comfortable for you to say, well, if he ended up with 1,032 and he started with 750, I'll just subtract because that's what the interest is, then great. That's fine too. As long as that's comfortable for you and you're getting them correct repeatedly, then that's perfectly fine. A couple of things I want you to notice here. We never use the formula for simple interest anywhere. Because this was about compound interest, we used the formula for compound interest that gave us the future value. Future value is important, but it wasn't the answer to the question. To get the answer to the question, we had a little bit more work to do, which involved using this formula to figure out how much interest was earned. Are there any questions about what we did here in this one? This is the top of the mountain for today. This is as challenging as they get. Using the formula for compound interest and making sure you answer the right question, which is how much interest was earned. Let me know if you have questions about this before I have you try one. Okay, let's see how we're doing here. How much interest is earned? If $4,000 is invested at 5% compounded quarterly for 12 years. I'll set up a poll for this. I'll give you plenty of time because there's a lot to do here, and I'll let you try it. Take your time as you work through this. Let your calculator carry the number forward. When you write down every step, there are a lot of them. Honestly, don't feel like these questions have to take forever, because the truth of it is, as long as you're sort of organized as you go through your steps, your calculator is carrying that number forward for you every single time. There are quite a few steps here. This is, like I said, this is the top of the mountain for us today. Honestly, this is the last problem we're working on today. So once we wrap this one up, we'll close for the week. But if you can solve this one, then you're in really good shape with compound interest. If you have trouble, I want to make sure you ask questions. If you're getting an answer that's none of the ones shown, I want to make sure you ask about that. This is definitely the type of question you can expect to see in homework, on a quiz, on an exam. So we want to make sure you're able to solve a problem like this one. Let's go one more minute and then we'll do it together. All right, let's see where we are. Okay, we have strong agreement, but not as many answers as I hoped for. So if you see something as we go through this that you're not sure of where it came from or how we got it, please make sure you ask. We read the problem. How much interest is earned if $4,000 is invested at 5% compounded quarterly? As soon as I see compounded in there, I know I'm going to use this formula. And then I go back and I read it again, and it says, how much interest is earned? Well, the formula for compound interest is great, but it won't tell me how much interest is earned. In order to get that, I'm also going to have to use this one. So I'm going to have to use these in conjunction with each other. First, I'll do compound interest. Afterwards, I'll figure out how much interest is earned. Okay, so if I want to figure out the future value using the formula for compound interest, let's see, 4,000 is invested, that's my principal. 5% is the rate, compounded quarterly. Okay, so that means n's going to equal 4. Quarterly, 4 times a year, and 12 years, that's my time. So as we plug in, we'll have the future value is the principal of 4,000 multiplied by 1 plus the rate, 5%, as a decimal, over 4. This time n is 4 because it's compounded quarterly. 4 also goes up here, and the time is 12 years. If you see something that you're not sure of, make sure you ask. I'll do this one a little more quickly than I've done the others, just because my sense is you kind of have the hang of it from here, but if you see something you're not sure of, let me know. First thing we'll do is clean up that exponent. 4,000 times 1 plus 0.05 over 4 raised to the 48th. Now we'll start working inside our parentheses, and the first thing we'll do is we'll divide 0.05 divided by 4. And I get 0.0125 raised to the 48th. I still have work to do inside those parentheses though, so we'll do that. Add those two together, and that's plus 1.0125. That's going to get raised to the 48th power. When we do that, we get 1.8153. Again, I'll just leave that sitting there on my calculator because the only thing I need to do now to find the future value is multiply by 4,000. And I get 7261.42. If this question had said, find the future value, then we'd be done right now, and 7,261.42 would be our answer. But it didn't. It said how much interest is earned. So I'm not done yet. I don't need to know A, I need to know I. And so we're going to use the other formula of A equals P plus I to figure that out. And our future value of 7261.42 is going to equal a principal of $4,000 plus I. In order to get I by itself, we need to subtract 4,000. And what we're doing here is we're subtracting off the principal to see how much actually was interest. Those will cancel. And over here, we just have I for the amount of interest. And over here, we subtract those and get $3,261.42 as the amount of interest that was earned.